Hi class, we are on section 8.3. This is the product and quotient theorems. So basically what we're going to be doing here is we will be dividing and multiplying the polar forms of complex numbers. Okay, so we're going to take the r cosine theta plus ir sine theta, and we will divide them by another complex polar form. Or multiply them by another complex polar form. So it seems like it's very complicated. These formulas are going to look very complicated. But the easy way around all of this, okay, the easiest way to do this is to take our polar forms, turn them into the standard complex form, and multiply them or divide them. That's the route that we're going to go. So there's just really an extra step. It's going from the polar form into the complex form, doing our math in the complex form, and then if necessary, taking that end result and returning it back into the polar form. Okay, so this is the way that I want you to think about it. Okay, doing math in the polar form may be very difficult. So what we're doing is we're going from one world into an equivalent world, right, where our form is easier for us to understand, which is the complex form. Do the math there where the math is easy, and then returning back to the complex form, to the polar form. So it's very similar to, let's say, when you're doing logarithms. Okay, so sometimes things are very hard or actually impossible to do in the exponential form. So what you would do is you would take your exponential form, you go into logarithms, do your math in logarithms, and then return to your exponential form. It's really the same kind of deal. The polar form will be difficult for us to do some calculations, so we go into the complex form, do our math there, and then return to that polar form. Okay, so that's the overarching idea, and that's kind of what I want you to keep in mind as we go through these processes, right? So again, we're going to talk about products in trig form, the polar form, and quotients of complex numbers in their trig form. Again, the trig form is the sine, cosine, or the cis theta, right? R cis theta. So if I have a complex number in polar form, so r1 cosine theta 1, I sine theta 1, this corresponds with the first number, okay? And I have a second number, so this is signified, notated with the r2 cosine theta 2, I sine theta 2, right? So the subscripts here tell us this all goes with the first number, and these all go with the second number, okay? If I take them and I want to multiply them, so again, this looks confusing, but all I'm really saying is this number times this number, okay? Then I can multiply them by multiplying their two radii and then adding their thetas together, okay? So again, that's one way to do it. The other way to do this is to turn these into complex numbers and do the math in the complex world, right? So honestly, I prefer to do that. I prefer to go back into the complex, but we'll kind of talk about both of them here a little bit, right? So again, here, if I want to find the product of 3 cosine of 45 degrees and I sine 45 degrees and 2 cosine 135 and I sine 135, we can multiply 2 times 3 and get 6, and then we'll do cosine of 45 plus 135, which will give me 180, and I sine plus of 145 plus I sine of 135, which will also give me 180, and then we can do that there. Okay, so that's not too bad, right? Okay, but you end up going into the complex world anyways to get the values, right? So again, you can turn this to a complex number and this into complex number and do the exact same thing. It's up to you, okay? Quotient, same thing. I have two complex polar forms, okay? This one does not equal 0 because it will be my denominator, it will be my divisor. You cannot divide by 0. So if I write it in this form, the formula is that I subtract the two angles and I divide their quotients. Or again, I can go into the complex world and do my math in the complex plane, right? So again, this is using the same formula but in the cis form. So here we will be subtracting the angles and dividing the moduli, right? So if I want to find the quotient of 10 cis negative 60 and 5 cis 150, I will subtract these two. Again, this one minus this one, so that will be a negative 210, and this will give me a 2, right? Okay, 2 cis negative 210 degrees. And then we can find the equivalent of this, which should be our 360 minus 210, so that'll give us 150, right? Okay, and we can use the exact values to find the complex value there. Okay, so now we want to use the calculator. Okay, so again, these are not nice numbers. So here 9.3 times 2.7, we can obviously do on the calculator. And then the cis of the 125.2 plus 49.8, right? So then we're going to get, what's this, 175 degrees, right? We just throw that into our calculator to get the approximate decimal form for our real and our imaginary values. Okay. Same thing if I divide. Okay. Divide these two values, right, which will give me a 2 because they're all doubles. And then this will be 3 pi over 4 minus pi over 5. Okay. So make your common denominators and figure this out before you throw it all in the calculator. And you can get your decimal approximation for this answer as well. Okay, very short video for today's lesson, so that's great for you guys. You're really just either adding or dividing those angles, and then you're multiplying or dividing, adding or subtracting the angles, and then you are multiplying or dividing the moduli for the complex vector plane.